So I need to put a couple of tapped holes in this for our little bar to sit in there, but I don't know how thick it is. And so what I'm gonna do, there's a million ways to do this. I'm just gonna use an indicator. And then we'll just lift the table up until we get a 0. Okay, so that block is 0. Then we'll go over here to our other block. Very carefully lift up on the indicator. So that tells us we are at 355 thousandths. But what I'm going to do to double check is use a depth mic. So that looks like 300 and, oh, we are getting, yeah, 6 thousandths. 356. So basically what that's going to do is prevent us from drilling too deep into the table and out the other side. All right, our pocket is all done. And there's our bar. Super overkill, but should hopefully help with the heavy piece of steel hanging off the back of the machine, or the back of the table. Should provide some force against that fence, either pushing out from clamping force on the tabletop or the weight of the plate itself from deflecting. You know, there's just a sliver of cast iron left after truing up the back of the table here. So I think it is necessary. Doing it this way in particular, yeah, probably not that necessary. But we do need to drill some mounting holes for this guy. I think the only consideration for position on this guy, obviously we want to be all the way up against the back fence or the back rib, whatever. And then on this side, I'm going to have screw heads sticking up that are supporting the insert plates. So I need to leave room there. This will all have to be assembled in a certain order. Obviously, you're not going to be able to get a wrench and the screw down in a space that small, but this should only have to happen once. A couple of cast iron clamps here, just to wedge this guy in position lightly. Just make sure it doesn't move around on me while I'm putting in my punch marks. All right, there's transfer punch. Very close to the exact size of our hole. It's a very nice close fit. Have to twist it a little bit to get it down into the bottom of the hole. And then just a couple of taps with the hammer should put us exactly where our hole needs to be. Voila. Yeah, that should work. Now we've got to be very careful here because the thickness of this plate is not very thick. And so we're going to use fine thread screws so that there's the maximum number of threads in that shallow depth. And take one of these and turn it into a flat bottom drill over on the Lyle drill grinder, just so we can get all the way down into the very bottom of the hole and make it, you know, full diameter all the way to the bottom. And then also probably modify a tap so that we can get full threads all the way to the very bottom of that hole. Again, you know, maybe not necessary. I think once this is held in place with those 4 screws, even if it is just a few threads, and then screws through the fence plate, sandwiching this piece of cast iron in there, I think everything's going to hold nice and tight. But I do want to try and do this as well as possible, of course. We are lined up on our mark there. Bit nervous about this, but you know, been nervous about other things that have gone fine, so hopefully this is also going to go fine. This is a 1/8 inch parallel, so I'm just wanting to get that to stop moving or pinch right there, and that tells me I am exactly 1/8 of an inch above the top of the hole. So bring the tip of the drill down onto our parallel and zero this guy out. Move everything out of the way. Come back down to our 0 and then subtract 125 for the thickness of the parallel. Just for some added insurance, here's our 1.5 thousandths feeler gauge, and I can force it under there with my quill DRO at 124.5. So if anything, we're just a little bit above where we're wanting to be, so that's good. And I think because of the delicate nature of this, I'm gonna raise the knee up into the work instead of using the quill to drill down, which is what I would normally do. But this will let us be a little bit more controlled and not overshoot our depth. And what we're shooting for, there's 355, 356 is the thickness of this, so let's shoot for 300, and fingers are crossed. $200. It's $250. $300 thousandths. Okay, hopefully that's enough to allow us to put a tap in there and make enough threads for this little project to work. Okay, it's my first attempt at using the Lyle drill grinder to make a 180-degree drill, and a little bit choppy, but it worked. I think that'll be just fine. That's not even with my modified cutting all the way to the bottom. That's just with the normal bottoming tap, so I think we'll be okay. There's 5 or 6 threads there. So yeah, I think I will survive this little plan. Yeah, 5.5 threads. That should be enough to provide the strength we need. Should work. Perfect. 2 more to go. Here's our little setup for measuring and marking the rounded corners for my table inserts. So this is ground stock, 3/4 inches wide by 3/8 thick, and I've machined the each end of each piece. So they are nice and parallel and straight and flat and everything else. So we need to add a 3/16 inch radius on each one corner of each of these. And the reason for that is we used a 3/8 inch end mill to cut out the slot in the table, the throat as I've been calling it. And so to do that, we're just going to use a couple of pieces that are the same dimensions. And in the corner here, we're just going to mark the steel with some die chem and line up the edges of our radius gauge and then scribe in the corner, and that'll give us a measurement to go off of. I'll do it on each side, and this doesn't have to be super precise, so we're just going to do it on the Burr King belt sander. If I had a 3/16 inch radius tool, I would use it, but the selection I have does not include a 3/16, so we're going at this a little bit crude, even though I'd rather have it precise. You know, I'm doing a lot of machining on this project that doesn't really require a lot of machining. Doing it because it's enjoyable. because we're dealing with abrasive and there's some little burrs on the work platform here and everything, I want to protect the nice ground finish on my part. It will later get totally scratched up, but at least right now while it's still brand new, I want it to stay looking pretty nice. So I just take some of this lovely powder coating tape. I can't remember exactly what it's called. It's got a specific name, but anyway, wrap that on there, and it's fairly dimensionally unimportant in this application, but it'll help me keep from scratching up the part. Here's one of our parts. There's the radius gauge. Not 100% perfect, but it's very close. Let's check the other one. Also very close. So there's our slot. I've just got a couple of Fireball tool 1 by 2 inch blocks in there, and then a parallel on top of it that's approximately the right thickness to have these sit correctly. And then we'll just drop our parts in. So yeah, I don't know how well that's going to show up, but they are pretty close. To improve the quality of the fit, what I've been doing the last couple of minutes here is just using my non-precision ground stone and just kind of honing the radius on the parts. Just kind of polishing that edge and making it more consistent and improving the fit of those even better. So I think at this point they're probably as good as they need to be, and then some. So what we need to do now is measure the back end and see how much needs to be removed in the milling process. All right, on the back end here, we've got a little bit sticking out as planned, and I'm just gonna go ahead and label these guys right and left. And then what we'll do is take the depth micrometer and one at a time here, take a measurement of how much needs to come off the end for these to be flush. So it looks like we need to be about 48 on that one. And that one is 56. So closer to the other two. They were about that as well. So now, just need to go over the milling machine and scrub off a little bit on this end. And then these parts will be ready for drilling and tapping underneath once we get there. Basically what's gonna happen here is the cutter is going to pinch the paper against the steel and sling it towards the column of the mill. So once it does that, I know I'm 2.5 thousandths away from the part. That's all it was, 48 thousandths. Now that our parts have been milled to size, test fit them in here. And let's go ahead and put the fence plate on the back here. I think that's going to work. So I've got a feeler gauge here, 1.5 thousandths. And just barely kind of start going in right there. Nowhere else though, maybe at the very end here. Nope. So we've got a nice good 90-degree joint there, and even though this is all completely crazy overkill, I did want it to be nice and precise. If I'm gonna go through all this effort and hassle, I may as well do a good job, right? So when I've got a piece of material in the saw to actually cut it, the blade's gonna run through there, of course. And when I bring in my material, obviously those will be raised up just a little bit when they're actually installed. But I've got a nice 90-degree corner, and the ground bar that my vices, or the fixture is going to be pushing with, is going to be nice and parallel to this, and should clamp material nice and sturdy without excessive pressure, and hopefully perform the way I'm expecting it to. And since these are now cut, let's go ahead and take their measurements off so I don't get mixed up and take more off. But yeah, there we go. I think that turned out pretty well.